So section 8.2 is on properties of parallelograms. We'll define what a parallelogram is, and then we're going to use the properties of parallelograms to find a lot of interior angle measurements. So a parallelogram is a quadrilateral that has opposite sides parallel. So in this picture here, we have quadrilateral ABCD, and we know that the AB and the DC lines are parallel because they have one little arrow pointing in the same direction. And we know the BC line and the AD lines are parallel because they have two lines pointing in the same direction. So those are the symbols that we use to show that lines are parallel. And again, we have quadrilateral or parallelogram ABCD. That little symbol in front of the ABCD, that is for parallelogram. So you can either write it out or you can do that little symbol. If a quadrilateral is a parallelogram, then the opposite sides are congruent. If a quadrilateral is a parallelogram, then its opposite sides are congruent. Okay, so the first thing that we're going to have to do to do this proof is we're going to have to put the information in about it being a parallelogram. So if it's a parallelogram, then the opposite sides are parallel. So we have those parts are parallel. So that's what I draw in there to start the proof. The next thing I'm going to do is I'm going to draw an auxiliary line. I'm going to draw an auxiliary line from D to B. And in doing so, what I have done is I have made two triangles. And I'm hoping that you guys are going to see that this is what we're going to use to do the proof is we're going to prove triangles are congruent. And if the triangles are congruent, then their corresponding parts will be congruent. And then that's how we're going to show that the opposite sides are congruent. So right off the bat, by drawing the auxiliary here, this angle and this angle are both one clicky, because if parallel lines are cut by a transversal, then alternate interior angles are congruent. And then up here, we have a two clicky angle and a two clicky angle, because again, if parallel lines are cut by a transversal, then alternate interior angles are congruent. And of course, this is a shared side. So how are these two triangles that I made, how are they congruent? What's our shortcut? Everybody, the answer is? Angle, side, angle. So we have angle, side, angle triangles, and then those corresponding parts are congruent. So CPCTC to show that AB is congruent to DC and AD is congruent to BC. That's the proof that if you have a parallelogram, the opposite sides are congruent.